All right, thank you very much, Dr. Mukherjee. Are you able to hear me okay?
I'm able to hear you okay, yes.
Very good. All right. So I'm going to share my screen. We'll begin by looking at our desktop client. So are you able to see the desktop client?
Well, it just went away. Yeah, I could see it, but it disappeared.
All right, let me go back and see what's happening. Are you able to see it now?
Not yet. Gary, yeah, okay, now I can see it, yeah.
Okay,
yeah, sure,
great.
Bill.
Okay, so Global IDs has two platforms. One is a desktop environment. That's what you're seeing on the screen here. There's another that's a web environment. This desktop environment is generally used by administrators to get the system set up, but from that point on, most customers work in the web environment. A lot of the capabilities that Dr. Mukherjee spoke of towards the ends of his presentation are represented by different modules that are exposed in this desktop client. I'll work from here, so my agenda today is to go through and give you a brief introduction to how the actual software works, and then spend some time on the architecture. How does this actually work at a small scale, and how do you get up to something that can scan 30 or 60,000 databases? And then finally, give you an overview of the API. So it has a full REST API where you can get access to essentially all of the things that I'm going to show you in the desktop client are accessible through REST APIs. Every single database in the environment, every schema, every column, every domain, and I'll explain more what a domain is in a minute, gets a unique identifier, and then there's a URL for it, and you can use that to integrate with other applications. So what you see on the screen is you can think of these icons as apps, and that the layers of the software that Dr. Mukherjee went through are organized over on the left in the panel. And so if I look at our data discovery layer, which is essentially around transparency as well as profiling, what you'll find is that the primary tool is something called DB crawler up here at the top, and I'm going to go into that and show you what that does. This is the tool that you would use to go in and make connections to databases. So on the left, what we see here looks like about 10 connections in this environment, and that in the middle, what you have is this complex graph that's showing all the tables and the schemas and the columns there, and you could drill into it if you chose to here, but you can imagine that if you went to 30,000 databases that this would be enormously complex, that no one could make sense of that. So what the software does is it begins to organize this. So at this point, all you've done is provided connections to databases and hit go, and it's gone off and begun scanning and profiling and collecting metadata. And it can do this at the scale of 35,000 databases over 4 months. So what I'm going to show you next is our Taxonomy Manager, which is software that's going through each column of data that is discovered, and it's attempting to classify it. So the question around SSN, how does it recognize an SSN? It's looking at the values that are appearing within the column. It's looking at what Dr. Mukherjee described as the shape of the columns and distributions of values. It's also looking at other domains that are in proximity. So a social security number could be a 9-digit number that could mean anything, but when it's nearby columns that represent people's names, which the software can also identify, it begins to give it more confidence that what it's looking at is not just any ordinary 9-digit number, but it's actually potentially a social security number. So that's sort of the basis of it. And so what you're seeing here is a graph of the different domains that it's discovered. Some of these are auto-generated. Some of these are what we call global domains. So out of the box, Global IDs recognizes concepts that you would find across industries, U.S. postal addresses, countries, and it has subdomains. So if we look at a country domain, we can see, for example, the various, so this particular domain was mapped to something that was a zip code and a zip code. We can go from domains that are known to global IDs to ones that it discovers. So in this case, QSIP ID. And we can see here that this QSIP ID has been mapped to a column called Tran ID in one table, and we can scan through and we can see all the various places where it's identified things that appear to be QSIPs called by a variety of different names. And up to this point, all of this has been fully automated. This is the point where you might have a subject matter expert come in and help quantify or clarify or identify things that may have been false positives. So what you see on this screen is every column, every table, every schema that it believes represents this thing that's called a QSIP. It didn't know what a QSIP was, but it found it, and it derived a name for it based on some of the columns that it found. And so here you see 3 check boxes. These represent a human has gone in and said, yes, in fact, these are QSIPs. But these other columns, it gives you a confidence. It says, this is what these appear to be. So you go down and you can look at the metadata that's associated with it, or it can actually, if we have a connection to the database, you can actually inspect values. So the next thing that I'm going to show you is that this is very helpful. This saves a lot of work in trying to identify where things are. So if you're trying to do load data into a Hadoop environment and you want to know where all the possible sources are, just give you a first cut at it. But what you'll find is when you get to 35,000 databases that it's very difficult even with this level of automation to be able to make sense of all the different places, because this graph gets very complex as well. So in a complex environment, you could have things like over 20,000 columns of data across thousands of schema that map to email address, and that's what we found in one environment. So what you need is another tool to be able to make sense of that, and that's what this semantic mapper tool does. So the first thing that the software is doing is it's looking at domains, these columns of data that represent the same concepts, and then it goes out and it says, okay, let me find things where I see the same combinations of domains occurring frequently together. So email address would frequently occur nearby a column that has a person name. So it might be an employee email address, or it might be a customer email address. And that other column may be in the same table. It may be in a table that you can join to, or maybe in a table that you can join from those tables. So it's doing what we call domain graph analysis. It's looking at each domain and it's saying what's nearby, and it comes up with candidate objects. So for instance, here we have an object that is an order ID, order info that is derived. And we can look at the mappings that it's discovered. And again, at this point, this is fully automated, that there's nothing that a human had to do to get to this spot, that it gives you a way to look across an enterprise and see the types of things that presumably, if you're coming in cold, are meaningful to that particular organization. So here we found something that looks like order info. It's found frequently these domains together in clusters, and then it's saying, okay, here are all the different places where I have things that have these domains regardless of what they're called. And this is all based on inspecting the values or samples of values and doing statistical analysis to try to derive this graph. So this is a good first step, but what you find is that these candidate objects can be, they're a good step at being able to understand what exists in an environment you're going into cold. But what you really want to do is be able to map specific sources to either an existing target or a proposed target. So we provide a couple of means to create what we call semantic objects. And there was a question earlier about Spark data frames. And you can think of a data frame as a collection of columns. And that's essentially what a semantic object is. It's grouping together columns that are relevant in a particular business context. At the simplest form, it's just one table, but it can be also relationships among tables. In this case, I can create an object either by going in and asking the software to add it from a table. So if I have an existing table that represents this object that I want to map to, for example, you're working in money laundering and you've got Actimize as the target model. You would profile Actimize, and then you would go in and say, okay, show me a table that I want to find sources for, You would point this software to that table, it would scan it, and then at that point you end up with something that looks like this. You can look across your landscape at things that it's already discovered. What we see here are the different connections, and you can see the different tables that it's found, and in parentheses you can see the number of columns that have been mapped to. These are suggested mappings. So I could go in, for example, this thing that's settlements looks promising because it's got 5 objects, and I can drag it into the environment, and then it will do the mapping for me. So this operation that you just saw is typically what you see in organizations happening with Excel spreadsheets, that they want to do source to target mapping. Someone saying, okay, tell me all the different columns in my target database, show me this subledger database, show me the mappings between them. This has been done automatically. But software can go and do automatic mapping too. So it can say attempt automatic mapping. Those take a couple of minutes, but it's essentially going through the metadata repository, everything that it's scanned so far, all of the domains that it's discovered and mapped, and it's saying, show me objects that appear to be this thing that I've created, either by scanning a target database or constructed by simply composing it using individual domains, and I got a mapping. I got a mapping very much like what it automatically found for our order info object. If I zoom in, what we'll see is here's our semantic object, and then over to the right are all the various objects that it found that appear to be these objects. So this is a big time saver that you can imagine trying to do what you just saw on the screen using Excel spreadsheets and a team of architects or subject matter experts doing source to target mappings. Or imagine that you're trying to integrate 2 companies that have just merged together, and you have subject matter experts from both sides that understand something about the sources, but they don't understand the union of them. Being able to go through and create this map almost instantaneously is a huge, huge step forward. But the problem that you'll run into, again, if you get to something that has 35,000 databases, is that this graph will be huge. And one of the reasons it's huge is because this data is flowing from system to system to system. So what is identified here are not necessarily the sources of the data. These could be derivatives of each other. So we provide a capability that Dr. Mukherjee was talking about, which unfortunately I don't know if this one was actually, that it attempts to sequence those tables that it found. In this case, this product hub appears to be coming from SalesDB and flowing downstream to RDB. So how does it do this? There's 2 techniques. So one is a static analysis where you don't have access to data in motion. Maybe you're looking at how does data move within a data warehouse, and that you'll have tables that have similar data and that through ETL flows it's flowing from one to another. There are often timestamps either in the table itself or in tables that can be reached through joins from the table that give you an indication of when the records in those tables were created. So by comparing Venn diagrams of samples from tables, you can begin to hypothesize about how the data is flowing. And then inspecting columns that have timestamps, you can confirm those theories. And so this is also fully automated, that it's suggesting this is the flow. And so this helps you if you're saying, I want to integrate a particular table to my downstream model. Is this really the one that I want, or do I want to go upstream and get it from the source? And so again, if you're coming into a foreign environment where you don't necessarily know all of the different relationships among the data, that you're traditionally relying on subject matter experts who may not be readily available when you need them to be able to help you make sense of the data. So you can begin to focus in on the tables that actually make sense, the ones that you plan to use in your project, and ignore the other ones that are potentially problematic. Am I still on? I just saw the GoToMeeting.
Yeah, Bill, you're still on. You're still
on. Okay, good. So the next step that generally happens in a project is you've done your mappings, that you've identified sources. These are your targets. The software's told you potentially how these things link together. The question is what's the state of this data? Are all these columns in here in this column actually populated? Are these actually going to be useful? Or are you going to have to accommodate data quality errors as you go through this? So I'm going to skip to a different tool. This is our metadata crawler, and this comes through profiling. This will create summaries of tables. This is automatic out of the box. As soon as you finish your initial profile, the results that you get are a summary of the characteristics of the data. So you get a bird's eye view of things as you come in that says, well, this is 100% unique, which is good for a primary key column. But you can also see things that look like they're a bit problematic, that they're empty columns. So you get a sense as you look at these charts that what is potentially problematic or what is actually good data. And there are a large number of different metrics and information that are computed at time of profiling that you can get to by inspecting these. What's also interesting is outliers. So as it goes through the software, or as the software is going through a database, it's looking to see what is the normal distribution of different things, normal distribution of lengths, normal distribution of data types, of frequency outliers, and flagging things that look like they might be suspect. And I'm not sure what this particular one is, but let's take a look at it. So here it's computed that the length of 52 looks suspect. That may or may not be a useful example in this case. We can look at data types, so state codes. Here state codes are generally text most of the time, but here it's found some 13 that appear to be numbers. So we look at those, we look at a number, and we can see it in context. So here this column that's called state is actually a number. So one would say that's probably an error, and they can mark that as a verified error. Or if, in fact, a number is valid for a state, you can mark that as a false positive. And from that point on, the software gets smarter about how it begins to make sense of the data. So now I'm going to move, unless there are questions, I'm going to move over to our web environment so that we can take a look at how this data is used from other